So we're going to be talking about the combined gas law today. Last time we talked about the ideal gas law, and that's great for looking at just one instance in time. But the combined gas law is specifically designed so that we can look at what changes if we change the different variables. And so when we see that, we have this equation. So we have P1V1 over N1T1 equals P2V2 over N2T2. Now we need to pay special attention to whether we see words like initial or final next to any and all of the values, because unlike with the ideal gas law equation, just because it's atmospheres doesn't mean that I necessarily know where to put it in my equation immediately. I need to watch for words like initial and final because I have two values. The ones are always going to be initials, the twos are always going to be finals. Other words can signify the initial, final, before, after, stuff like that, but always my before manipulation is going to be ones and after manipulation would be my twos. So here is an actual example equation, an example problem that we could see with the combined gas law. Initially, you can look at it and you can see that this problem is significantly longer than any of my ideal gas law problems, and that is because I have significantly more variables in play. As you can see, I went through and I underlined stuff with different colors. I highly recommend this. I color-coded my initial equation here, and I color-coded the numbers that I found inside of the English problem to help me figure out what I need to do with those. So as you can see, it says the initial pressure. So that means I'm going to be dealing with my P1. So it says my initial pressure is 3.7 atmospheres. Since atmosphere is a unit of pressure and it told me the word pressure, I went ahead and I underlined it with purple. Now the word initial generally tells me that it's going to be my P1. So I'm just going to kind of keep that in the back of my mind right now, and I'm going to keep reading and looking for other variables. When the 8.3 moles is my unit for N. Remember, it's the number of moles. So my 8.3 moles I underlined in green because N is green in my equation. Of the gas occupies 5.5 liters. Liters is my unit for the variable volume. So I went ahead and I underlined it in that bluish color. And then I'm going to keep reading and see that when the temperature is 298 Kelvin, so Kelvin and the word temperature tells me that I'm dealing with a T, and since my T is this like reddish maroonish color, I went ahead and I underlined it there. Then I start seeing my question word. That to me generally signifies that those are going to be my initials. Those are going to be my 1 values. So then it says, what is the final pressure? So I'm going to go ahead and I'm going to underline that because the question word is attached to the unit pressure. So I'm going to go ahead and say that I'm looking for my final pressure, and I underline it in purple because pressure is purple. If the temperature is increased to 250 degrees Kelvin. So Kelvin, again, is my unit of temperature, and I'm going to go ahead and I'm going to underline it. Now I'm going to go ahead and I'm going to pull all of those numbers out of the English. The English is gross. It's hard to look at. You don't know what you're looking at. It's just kind of difficult to find the stuff that you need. So we're going to go ahead and we're going to start translating all of the things. And the very first thing that I always like to do is I like to define everything that my problem actually gave me. So I'm going to go ahead and I'm going to look for all of the variables that I know. I see pressure, and I'm going to go ahead and I'm going to define pressure. My P1, I know from it saying my initial pressure was 3.7, so I went ahead and I defined P1 as 3.7 atmospheres. And then I know that my other secondary purple was just attached to this question word, what final pressure? So I don't know what my P2 is, so I went ahead and I signified that with a question mark for that. Now the next color, the next variable that I see is green, and that is my N. And since my green, my N, my mole number is before that change, I'm going to go ahead and I'm going to signify that as my N1, and that is going to be 8.3 moles. And then the next color that I see is this little bluish color, and that's going to be my V. And since, again, it is before I change my temperature, I'm going to signify that as V1. And then I see my maroonish color. I see my temperatures, and I'm going to be super careful here because I have two temperatures. I have to be careful which one's final, which one's initial. I know that 450 Kelvin will be my final temperature because it says that the temperature is being increased to this. So a change has happened. So my 450 Kelvin is going to be my final, my T2, which would make my T1 the first temperature that was stated, the 298 Kelvin. Okay, that was before the change. So that's why I know that that is my T1. Now that I have everything down, I'm starting to notice that only two of my variables have a before and an after number, okay? And I am going to go ahead and realize that and discard any of the numbers that I don't actually need. Since N and V do not appear twice and are not the desired variable, I do not care about them. It's extra information that I don't actually need, so I'm going to not use that in my math at all. And what I'm going to do is I'm going to remove N and V, both N1 and V1, from my actual initial equation, and I'm going to solve for the unit that I actually want. P2 is the unit that I actually want, and whenever I actually went ahead and removed N and V from both sides of my equation, I ended up with P1 over T1 equals P2 over T2. And when I solved for P2, I went ahead and I saw that it was currently being divided by T2. To undo a division, I need to multiply. And so I multiplied both sides by T2. That isolated P2, and it gave me P1 T1 over T1 is equal to P2. Now that I have my equation isolated, I can go ahead and plug in my actual values that I defined up here in my little shortcut cheat code thing, so I don't have to read the question again, and I can go ahead and start solving that problem. Now I see that my P2 is set equal to P1. P1 was up here, it was 3.7 atmospheres. Multiplied by T2, so I needed to pull my T2 number, which was 450 Kelvin, and I'm dividing by my T1 number, which was 298 Kelvin. When I do that, I see that Kelvin cancels, and I'm left with the unit atmospheres, the only English left in my math, which is an appropriate unit for pressure, so I can go ahead and plug it into the calculator, and when I did that, the number that came out of my calculator was 5.587248322. That's a really gross long number. I went ahead and said that I was going to round it to 2 decimals. 8 is the last number that I care about. I looked over to see if I needed to round up. 7 did make me round up. So my final boxed answer was 5.59 atmospheres.